This is Chapter 8, Part 2. In this video, we're going to talk quickly about thermodynamic control versus kinetic control. And then later in this chapter, we'll talk about how this applies to some of the reactions in this chapter. So first, let's look at these reaction coordinate diagrams comparing a kinetic control situation versus a thermodynamic control situation. In kinetic control, you can see this reaction depicted by the green reaction coordinate diagram. And you want to make a couple of notes here when you're comparing it to the pink. One, look at the activation energy. The activation energy is lower than the thermodynamic control situation. So when you have a reaction that is kinetically controlled, you have a lower activation energy, meaning that this is a slower reaction. Also notice that the product is not as stable. So in the kinetic control reaction, we have a greater activation energy, which means this reaction is going to take more time, but when it does, it is going to be more favored overall. So you can look at the overall delta G of the reaction is greater. So this is a more favored product when you're looking at thermodynamic control. Let's look at some of the other factors that are associated with these two different types of reactions. So you can see a quick summary here, but in kinetic control, the reaction occurs faster, right? Because we have the lower activation energy, that's a faster reaction. Thermodynamic control means that the products are formed slower. There's a greater activation energy associated with it, or a greater delta G double dagger. The kinetic products also have a more stable transition state. So if we're going back to look at this reaction coordinate here, the transition state here is lower, so it's going to be more stable than the situation with the thermodynamic control where the transition state is higher in energy, so the transition state is less stable. Kinetic products are going to be favored at lower temperatures. Typically what you see is that if you add heat, you're going to get a thermodynamic product. And then if you run a reaction at room temperature or possibly even lower, you're more likely to get a kinetic product. And then of course with the kinetic products, we mentioned that the final product is less stable, whereas with thermodynamic products, the final product is going to be more energetically stable. So we're going to come back to kinetic versus thermodynamic products later in this chapter, but that's just kind of the quick introduction.